Hello dear viewers, a very warm welcome to our channel. In this video we are going to have a look at the horn. We'll be looking at the internal construction and principle of operation of this horn. This is a 12-volt electrical horn. As you can see, these are the power supplies. There is a coil in here that will be energized when electricity is supplied to these two terminals, and when power is supplied to these two terminals we will hear a warning tone that will signal presence of a vehicle. Let's open it up and have a look at the internal construction. As you can see, there are different parts. Right here there is a tone plate. This is a tone plate. This is a plate that is used to generate the tone. Let's open up and see the internal. This is simply a hold down assembly to keep all components and the diaphragm in place, and followed by a gasket. There is a gasket here. This will isolate the spring plate from the cover so that it can freely vibrate. And right here we have the diaphragm. This is a spring steel diaphragm. This is a spring steel. It's constructed from a very tough spring steel, and there is an armature that is getting pulled into the magnetism. And if you can remove this, this is a tone plate. This is used to generate a specific tone. A specific tone. It can generate a specific tone. And right here we have a diaphragm. This diaphragm is actually made up of a spring steel. Spring steel, when magnetism pulls it down, when it is pulled down, this assembly will pull it down. The ends are prevented from moving by the screw, and this will be sucked into the magnetism. And when the magnetism collapses, it will come back and it will oscillate in such a fashion. It will have a very high frequency. The frequency of this diaphragm oscillation can range from 200 to 500 Hz. It means it can vibrate as much as 500 times per second. So that is the oscillation. The oscillation of this diaphragm is from 200 to 500 Hz. Now, when you look at the magnetic part, right here we have the electromagnet. Below here there is an electromagnetic coil. That magnetic coil is prevented from moving by this hold down assembly. The hold down assembly is actually riveted here. There are two rivets fixing it to the housing, so there is magnetism. When these two terminals are supplied with electricity, there will be magnetism that is generated by this coil. When magnetism is generated, this armature will be pulled into the magnetism. Let's remove this. So the idea is this will be pulled into the magnetism. When this is energized, when there is magnetism, this assembly, this armature will be pulled into the magnetism, and that will move the diaphragm down. It will pull the diaphragm into the magnetism. Now, as you can see, there are contact points right there. There are contact points, and the lower part of the contact point is movable. It can be moved. Now, the downward motion of this will press on this metal and open the contact. So this moving down, it will open the contact point. It will open the contact point, causing current flow interruption. So when this is pressed by the armature plate, it will open and current flow through the coil will stop. This time, because of the spring nature of the diaphragm, this diaphragm will spring back. This diaphragm will spring back. It was initially pushed down on the middle. When there is magnetism, this is pulled, and then when magnetism collapses due to the spring nature, this springs back. Now when it springs back, the whole assembly will spring back. That will put the contact point to close again. And once it is closed, magnetism will be generated. It will be pulled again. So this cycle repeats. On, off, on, off, on, off, on, off will repeat 500 times per second. This is a very large frequency. So it will vibrate, it will vibrate, it will vibrate. And that vibration of the diaphragm will generate sound wave that is to be characterized as an audible signal generated by the horn. So this is the principle of operation. Now, in order to ensure very fast magnetic field collapse, and in order to prevent arcing at the contact point and elongate their service life, a capacitor is connected. Right here you see a capacitor that is connected in parallel to the contact point. Here we have a capacitor condenser that is connected in parallel to the contact points. By connecting a capacitor in parallel to the contact point, one, you can increase the service life of the contact point, and you can also ensure very sudden collapse of magnetism. So rapid collapse of the magnetism is ensured by the use of the capacitor. Now the rate of this on-off, the rate of on-off can be adjusted by altering the position of this upper plate by simply rotating this screw. This is a tone adjusting screw that will manipulate the upper contact point. As you can see, the upper contact point is supported by this plastic surface, and that plastic is connected to this tone adjusting screw. So by changing this height, by changing the height of this screw, you are simply changing the amplitude of this. The pulling of this can be changed by simply changing the position of the contact point relative to the diaphragm. By changing this, by altering this, you can change the audio of the horn. So this is the principle of operation. Usually these contact points, they get bad when horn stops working. Usually the contact point, they will have carbon build up. So by simply opening and cleaning it with sandpaper, you can fix it. And the other issue is there could be a coil failure, but that is not frequent. The frequent failure is usually on the contact point. When the capacitor goes bad, this excessive arcing at the contact point will run the surface rough, and that can generate a carbon deposit that will hinder electrical conductivity. So if it is a detachable type of this kind, you can open it up and you can use a sandpaper to clean the contact points. You can use a piece of sandpaper to do the cleaning. You can fold it in half so that both side contact points can be cleaned, and simply insert it in here, press it down, insert it in here, clean it in such a fashion. Once it is inserted, you can simply by doing so, you can clean the contact points. Once the contact points are cleaned and carbon deposit is removed, then electrical conductivity can be restored. So this is a simple maintenance task that you can do in order to make sure that the contact points are working nice. It has to spring back. This, when you hold it down, it has to spring back. It has to spring back. And adjustment here, let me show you what the adjustment screw will do. This is the adjustment screw. You can move it here and there. Moving it will change the height of the upper contact point. Moving it will change the height of the upper contact point, and it will change the relative position. So this is how you can adjust the tone of the horn. Now let's go ahead and assemble it back. Here we have a gasket. Gaskets prevent water admittance into the system. There are some horns that cannot be opened like so, where there is no screw to be removed. In that case, in order to clean it, you can remove this adjusting screw and you can spray electric contact cleaning fluid in order to clean the contact point. Some used to use it, some people clean it by using kerosene, or some use it by using gasoline in order to spray it in and clean the contact points so that electrical flow can be restored. But when it comes to an open type of this kind, you can simply open it up and clean it up. Always make sure that there is no water getting admitted into a horn, because water is the main damaging factor when it comes to horns. This spring plate, it has a cover, but if it is exposed to long period of water, it might result in rust, and that will prevent the full vibration and effective tuning of the horn.